All right, here we go. It's a lot of information. I'm going to be talking pretty quick just to let you know. But if you need to ask any questions afterward, my email is available, and I'll be able to get back to you, but I might not be able to touch on every topic today. So I'm going to get started because it's a lot of information to cram into this 18 minutes. So here we go. With architecting an enterprise GIS environment, the first thing you look at is like, what are your users? Are they going to be just your team? Are they internal? Are they external? Are you reaching out to the public, the internet? Do you have other teams in your office that you're going to be working with? What kind of devices are there going to be? Are they going to be just laptops and computers? Are you going to be using tablets and mobile devices as well? How is your relationship between the GIS and the IT team? Do they work together? Is there a diverse range of skills? And will the IT team be handling anything? And can they take the load of any changes? These are things that we kind of considered with our group, and we found out that, you know, of devices, majority of people that utilize our GIS stuff outside of our office are mobile users. It's all, for the most part, 55% mobile phones. Most of that being Apple. So that was something that we needed to cater to application-wise and such, as making sure the things that work on mobile devices. Our user base is very large. You know, we have 30 departments in the county, but we actually have services and work for 20 of those 30, with the rest of them utilizing our services in some way. The public is huge for us. We had an increase of over 180,000 new users in the last 60 days alone. It's increasing every single month. And so something to think about for us is, at what point do we need more resources to handle that load? Because just because there's 180 users doesn't mean there's 180 hits. That means we have over 500,000 hits every month or so. So that's a lot of work for a server to take on. Other government agencies, we share data across. They share it with us. We host things or copy things. They copy things. It's a relationship that we have to be cognizant of and cater to a little bit, so that we can share and keep that open between the two, because we can help each other a lot. What are your goals? We really liked to have good uptime. You know, we were shooting for a certain percentage. Security-wise, we have, you know, numerous firewalls and such already in place on our network, but then also we had secure data concerns. We had some sensitive data, some HIPAA data, and how do we keep that separate and secure from everybody or from everything else? Do you have a distributed workforce, or do you want a distributed workforce? Is there going to be a distributed workforce? I mean, right now we're all remote workers. That's something to keep in the mind. If going forward, if everybody works remote or not, that changes the way that you design your enterprise environment. Are you looking to collaborate with other teams or offices? You know, that might be a way to share things. Are you looking to integrate with anything existing? Like, we have a cartograph system for McDOT that integrates with our system that we had to be cognizant of. We also have some stuff going to like the 911 and computer-aided dispatching systems. So these are things that we had to think about, and if they could go in and how, because some of them require certain settings or certain configurations different from others. What are your monitoring goals, and how are you going to manage that insane flood of alerts? I mean, there are days where we've had 7,000 in less than an hour. How do you manage that? You're not going through 7,000 emails in an hour. And then how adaptable and scalable do you need to be? For us, that was huge because we're always growing. Your hardware and software needs. You know, we rely really heavily on Esri enterprise software. We try to spec out for everything, even if we aren't using it, and we try to hit above the minimum resource requirements. But if you can't, you know, determine which pieces you do need and what those resources are. Do you want anything non-GIS but that can still help, that isn't cloud-based? You know, we use FME a lot for data moving overnight. We have Elasticsearch and Kibana as well on site to help with some data mining and data analysis. We also have some monitoring software on site. So those are things that we've had to add into our architecture. Do you have data to store? How big is it? You know, are you looking at databases. Like we mainly use Microsoft SQL Server. We have a lot of file servers as well. Some things to keep in mind are people editing? Is there going to be versioning? Because those can get large very quick. And then also, do you keep those separate from editing or from publishing environments or sensitive data? Do you need a scalable environment, such as an active passive? That's the model we typically follow, to where we have a duplicate of each. One is active at a time. If something happens, we roll to the other one. And then if we need double the horsepower, we put them both active, and we have double the load out there for if we're getting hit really hard or getting a lot of traffic. Do you have an IT team that can handle physical or virtual machines, or do you need to go fully to the cloud? You know, some people have a very small IT shop, so all of a sudden spooling up a huge virtual environment like we have with over 200 servers, that's a lot of maintenance to maintain for a couple of IT people, so it's just unmanageable. In that instance, you know, you'd probably be looking at a cloud where they maintain all that for you, even though it's more expensive. Do you need to have certain things on-prem, though? I mean, I understand in certain distributed environments, there are things that need to be on-prem that can't go in the cloud. That's something to also keep in mind if you want to be completely in the cloud, that you may not be able to be 100% because of those things. Do you need things that are more resource intensive? You know, are you looking into 3D machine learning, data analytics, data mining, and then how are those resources going to change? Those are things that we are definitely into and increasing all the time, and they make a big difference on your resources. This is an example of the active passive site that we use. This is a screenshot from Esri. We use a third-party load balancer to web adapters in our DMZ, and then they go down to our server site with file servers that store the actual configuration stores and such for the ArcGIS server. So it's not on the same server as ArcGIS server, so it can share, because we have numerous servers in the same ArcGIS server sites. We hit 99.5% availability last year overall, which is 50 minutes of downtime a week, which is pretty good considering we maintain it in-house and not in the cloud. That basically was a patch day a month, you know, 3.6 hours. That was basically when we patch over the weekend. That was our downtime. This is an example of how it's set up. So we go through the firewall and a load balancer into our web servers in a DMZ that talk through another firewall into numerous ArcGIS server sites. So we have multiple web adapters in the DMZ that talk to the multiple server sites that we have behind the firewall on the intranet. And then this is a complete mirror copy. So there's two of it, and then we have a preview site that is a copy of that we use as kind of like our beta. So once we go from development to staging, those are only internal. So to see how things behave external, we put it out on our preview site and see how it behaves through the firewalls and stuff, because sometimes, you know, there's a port or a communication issue between the firewall, and that's someplace where we can test it. This is what we came up with. It's duplicated through everything: our development, our staging, our production, internal, intranet only, do not reach outside. Our external is split app and web is the only one that's in the DMZ that goes outside. App is completely internal and only talks through, you know, port 443 out to the DMZ and on. And then we do utilize ArcGIS Online for some things that are, you know, able to be outside of our network or need to be outside of our network. Monitoring, we do a lot of monitoring. Our web applications, we use Google Analytics a lot. It's, you know, we have like an active passive monitoring approach where we always have monitoring going all the time. But then there are certain times where we want to do specific things, and that would be like our passive, like we want to be able to do this random thing this one time, and these tools allow us to do that. So with Google Analytics, we can see a lot of data about the web traffic, if it's increasing, decreasing, if we want it to increase, that kind of thing. if we're having issues, we can use Fiddler or Wireshark to kind of see if there's a packet loss or some kind of like a debugging in a way of how the URLs are going and how the REST calls are going, and if there's something being blocked along the way on our end. And then we do have a network team that mostly handles the network, so we don't have to get too into that, but we can at least kind of do a little bit of troubleshooting on our end before going to them and being like, look, there's something going on here. For infrastructure, our data center uses SolarWinds to monitor the server environment, the virtual environment, but GIS has our own infrastructure monitoring, which is New Relic. We use it to monitor infrastructure and applications. We also use some of the ArcGIS REST API in some web pages that we use to run enterprise system functionality checks whenever we need to, like the health check command, for instance. Many scripts. Anything from Python and bat files, FME scripts, all scheduled through Windows Task Schedule, that kind of thing. And then if they have an error, they send it on to OpsGenie for an alert, and then that person on call gets that alert. We have our logs are not on the ArcGIS server or portal servers. They feed to a file server, so we can consume them separately if something were to happen. New Relic can also consume those, but Splunk can view them. So there are many ways to look at the logs, including the Windows logs, but we, look through all of those. Esri System Log Parser, it's a tool that they have. You can view the ArcGIS server logs as a desktop application. It's kind of like Monitor, but like not as in-depth and not as much that you can do with it. ArcGIS Monitor and GeoCortex will help with your services. If you need to monitor your services and send alerts, something's going wrong with your actual ArcGIS services. We use a lot of visualizations for things. We use Data Studio by Google to show dashboards and whatnot for Google Analytics. And we also have dashboards within New Relic to show, uptime and that kind of thing across our infrastructure. All of our alerts from everything you see here is fed into OpsGenie, where we have a on-call hierarchy that we've established that rotates around automatically. We don't have to do anything, and if something goes wrong, only the on-call person gets the alert, which is pretty useful with that many alerts. Automation, we are big fans of automation because it allows us to do more with less. It's more efficient, it's more consistent, the timelines of things are shorter, and things can be running 24/7, not just 8 to 5 when people are in the office. So any like routine tasks or workflows that are done over and over again, even some of our analysis is done automatically. You can scale automatically with code. We use TFS for pushing builds out for web applications. The Esri ArcGIS Enterprise has a lot of tools that you can use for administration, like the REST API. There's command line. There's the Python API. We use a lot of PowerShell, and something that we're getting into is Chef. Chef is pretty useful. You can also script upgrades and installs using command line and Chef. We currently don't have Chef, but we're working on getting it to make that process even faster and easier. Security, let's see. Most of it is built into ArcGIS Enterprise, but there are obviously things outside of that. For instance, we only allow HTTPS traffic everywhere, 443 everywhere, SSL certs on everything, and we don't use self-signed like we actually use CA, SHA-256, RSA 2048-bit keys. We don't use domain certs, and it keeps it secure. So there's a cert for every single server that we have, and it's imported into all of the software as well. We have firewalls. We have many different types of authentication depending on what the need is. We have SAML and we have LDAP. We have anonymous access off in certain locations. We have Windows authentication in certain locations. Portal. We have IIS, where we even IP filter down to only certain IPs can access things. There's so many ways to do authentication. A lot of us are TOC certified even, so if we have sensitive data, we've all had our background checks and everything, so secure data-wise, those people are the ones that can actually touch it and build and do things with it. We keep our web adapters separate, as mentioned. all our databases are encrypted. So our SQL databases are all encrypted. And I have a few tips and tricks. I'm kind of getting toward the end. I'm trying to hurry. Automate and monitor, big thing. Of all the tools that you guys saw, we spend less than $60,000 a year on this. With not including Esri, we spend $60,000 a year on extra tools. And some of that, I mean, you can start with pilots for free. A lot of them will do pilots for like 30 days for free, so you can tinker with it and see how it is, see if it'll work for you. We start a lot of new softwares with this method because that is how we know, you know, if it's going to be useful for us or not. See if you have something non-ArcGIS, like if there's something that you need to use to integrate with, see how that'll work and just make sure to plan for that. Documentation, there's documentation everywhere. So like, for instance, Esri even lists the ports you need open. Everybody lists their minimum resources required. It'll help get you in order for what you need moving forward. Relationships, you know, having a good relationship with people, like especially if you need to work with your IT group, it can be a bottleneck if you don't, if they need to be doing stuff for you. So that's a good relationship to have and to keep that strong. To plan for scaling, you know, every year things are growing, and plan on if you decide you want something that has a that is resource intensive, such as like if you want to start using geoanalytics, or if you want to start using insights for portal, or if you want to start doing more data mining, you got to remember those take a lot more resources than what you might currently have or what you might originally plan for. Skill sets, what does your team have? What could they bring? You know, we have a sysadmin on our team. We have a UX developer on our team who's learning GIS but wasn't GIS to begin with. So it's these outside minds that we have that have been very useful in bringing in the outside software and other things to use with GIS. Sandboxes are interesting. We have sandboxes set up to where people can try and play with things, and then if something happens, we can blow it away and build it back up. We can try all the newest software, whatever the current software is, and then we can even try like the older releases if we need to. It just gives them somewhere to tinker. Some things we're looking into, or some things to consider, is like we're looking at more cloud-based, you know, desktop editing in the cloud, a remote workforce. You know, we're all remote right now, but we still have a building sitting with a bunch of our computers in it. So that's not exactly, sustainable in the future if people stay remote. So we're looking at a more cloud-based solution for that. You know, we're always looking into containers. We're adopting a Docker one right now that they're looking into. The Internet of Things, always huge, tons of data. How are we going to consume it? How are we going to make it useful? We mainly focus on like machine learning, AI, and data mining for those. But it's a lot of data, so we have to make sure we have the space for it, and then we have to make sure we have the processing power for it. Fine-tuning, you know, there's always fine-tuning with ArcGIS Enterprise, especially when there's new releases. There's always tuning with new services you build, new apps you build. And then also automation. What else could we possibly automate? I mean, anything that we could automate, we're willing to take advantage of. I have a few useful links, or you can Google it. It's just a few of the architecture stuff for Esri on here, and plus that log parser. You can get it from downloading the slideshow too, so that you have it. But I think I'm a little bit over. So any questions?
Wow, Kacie, that is a lot of info. We might have to have you do a technical session at one point. So
yeah, it was really hard to squeeze it.
I'm sure. So it's not a lot of time when you got a lot of info. So there were quite a few questions in the chat, and we do have to get on to the next one, but I'm wondering, you can either address them in the chat, or for those of you that have questions, I can also, we're not going to hop to the sponsor breakouts, I can leave this open longer at the end of this session for more, so you guys can talk some more with Kacie. So thank you, Kacie, that was great. I'm going to find Bo on my list here. He is next up. And make you a presenter.
Should I show my screen? I suppose.
So, yep, you should be able to share. All right, let me tell people a little bit about you. Let me give them an intro for you. You got to follow up Kacie there. I don't know about you guys, have to follow that one. So many great presentations. Okay, for those of you that don't know Bo, because he's been around for quite a while with all of us, and that's a good friend, and presented at AGIC many times, always sharing his great knowledge as well. Bo has over 25 years of GIS and IT experience in the public sector. He's the founder of GIS Research, Inc., and is an active member in the AGIC community. He leads his team in designing and developing GIS applications such as AZGIV and EMAP that are part of the Arizona geospatial ecosystem. And Bo's going to talk to us today about spatial temporal roads and highways databases, and I'll let him take it over.
Thank you, Jamie. And maybe I should stop my video so we can have more bandwidth going for the presentation. Can you see my slides well?
Yes. Are you in slideshow mode? The slideshow hasn't started yet.
Yeah, maybe I can do a present mode. I don't know if you are seeing my slide this way.
That looks like the slides. Yep, that looks good.
Okay, very cool. All right. And good afternoon, everyone. You're most likely familiar with road and highway systems, a very popular and powerful LRS management platform from Esri. You may agree to a certain level. However, driving along road and highway can be disorienting, can be sometimes dangerous, and sometimes boring. Why I say so? Because without milestones, without references, stability and human understanding is not quite there. And here I'm getting a plugin for my article series on LRS, and Carol, my colleague, will post some links over in the chat window. Why I say no guide rails? Think about it. I think there's absence of a QC, especially at the QC at the edit time. And there's lack of operational clarity. And I will explain what I mean, what is meant by that. And there's no scenic view, and the UI is busy and old-fashioned. So today, and let's look at some of the pain points we just mentioned. And we are going to most likely, we'll show some slides and then talk about some of having a demo of one of our latest linear bench software called Linear Bench Ninja. So a little background here, event modeling and also event modeling is spatial temporal. You have typically, you have the route and from measure to measure, and you might have the beginning date and end date in this case. And we like to have, for human understanding, for stability purposes, we like to have route from measure with offset to measure with offset, essentially from intersection to intersection. So this is more desirable. And for intersection building, we have building to initial generalization, incremental build, spatial temporal, building to it, and also automated without UI. So essentially in the system, you don't have to do anything like that. And I think the visual, as you will see shortly, we have time-space diagram built into it. And regarding the data view, we have the grid form and also card form in addition to the classic map interface. And topology, boy, talking about LRS, I think LRS is more about topology than geometry. And how about events in the same layer? There's a topological relationship among them. How about cross-layer events relationships, right? And about events and the routes and their relationship. Certainly for us, I think on-the-fly topological detection is very important. And speaking of the operational clarity, and this is how Esri existing event editor does things. So you are in the edit mode. You can either retire or plus new or just edit, all in one mode. When you delete, you can do retire or just simply delete. And I think that fundamentally they're so different. I think we separate them into essentially 3 different categories. You can have update, which is completely temporal, in which case you have add, retire, revise. We use this different jargons to have the dimensional, temporal dimensional connotation to it. And correct. And correction mode, which is in red, essentially fixes any errors and also purge, completely deleting them from the database. You have the maintenance, which does not change the value, the essence or the quality of data, but certainly change the forms of data. Then here's the update operation, as I mentioned, in terms of revise. Remember, this is spatial temporal. And you have the original data, you have the effective date and current date. So rendering the ones below are being retired. And you can add an event, and this is adding a new event, rendering the existing, the earlier event being over here, right? And then same thing goes with retire. You set a retire date. Then correction is different story. Just what we understand what a typical update is. If you have an event like this, you say it's actually not as wide along, you just make this change along the x-axis and purge, essentially remove it. Then you sort of have the split and merge in this case, and you can, based upon different axes, to deal with this merge activity. With that said, and I would like to show a little demo here. So first of all, and we log into Roads and Highway. Well, expired. How about I try it again? Boy, initial. Okay. So if you're interested in Yuma area, you type in Yuma. It brings you over to Yuma. And I would like to only focus on the section crossing through the IA, let's say over here. And I would like to be I'm interested in doing ADT today. And it brings up only 50 out of them in this area, random. You see the sample here. So you can turn on to see how many of them. In fact, we have so many of them. We can also page them. So now 100 of them brings over. And for us, we're more interested in this area is actually I8. We just take press I8, select I8. So in I8, you see these are the different sections of ADT over here. And here we have the observation date set as today, okay, I8. Optionally, we can specify different filters and what have you to further refine your interest, events of interest. And here is the diagram, time-space diagram. This is the data view. And we are at explore mode, essentially reading, okay? And here, let's see how the different aspects are interrelating. Now I'm selecting this guy. On the map, you're only seeing the current record. But each and every record, they have a topologically related and temporally related attributes as well. So think about this. On the surface, just one record. Behind the scene, the things being related to it. There's so many of them, they are related. They're all displayed in the spatial temporal time-space diagram, if you will. And here I would like to show a little bit about the intersection here. So if we zoom out here, and the measures right now is based upon intersecting locations. These are internally built, spatial temporal enabled. And we can, of course, we can also pick into this, in this case, not only the from measure to measure being order measure like this, but also here the scale gets changed. Of course, being as human beings, we are more relative. We are more relational in terms of our cognizance of reality rather than actual measures, right? So we prefer this type of engagement, and you can pick different places to go. And as we move, you see the cursor on the map showing where we are as well, and you can zoom in, zoom out there. And one other thing is you can change space map. I always like Esri's space map, and its cartographic design and color matches with our style quite well, but you have option of picking others. You might also print your map, and if you print a map, is over here, even this cursor is being presented. First simple, then you can send over to others to have any review and what have you. But again, mostly today, we're going to talk about topological related issues, and there are a few ways we can explore topology, because topology oftentimes is hidden. You really do not see them, but they are everywhere oftentimes. And if we turn on this topology, it shows a few topological errors over here. These are all on the fly calculated, and later we'll see more of them. And in fact, if we hover over here, it should also identify places where we have extent and gap issues. So these are kind of, we're still refining this, but this is showing where issues we might have, okay? And now let's look at the, we talked about the switch. Let's look at zooming in into different areas. Right at this moment, we're zooming into different, we're panning and zooming into different intersections, right? In the measure axis. And we can also switch this over to temporal axis. In fact, this is so relevant. If we zoom into the temporal area, you will see the gaps. Here is a major gap, okay? And you will see overlaps. And if you zoom in further, you see so many data overlap. In fact, you can right-click on this, bring back and bring front to have many different attributes, colored in that particular area. Yeah, they are all the artifacts in the database, so to speak. Yeah. Okay, and temporal area. Yeah, and I'm trying to think. Now, let's look into, earlier I mentioned about the operational clarity. We have made this, we have the update. Update is always temporal. You need to have this on, observe date on, in order to do that. Okay, in fact, let's update this record for a moment, okay? So once we select this one, and we can go over, no, we cannot do correct. This is update. So in the update, and for this little piece over here, okay, we can change this. So I guess yeah. It's really small. Oh, yeah, in fact, it's actually a line. Yeah, so this attribute was not done right. And we're going to pick another one to do it today. And let's pick this guy. And let's go to correct. No, it keeps incorrect. Should be update. So update having this orange color. So I think the color as part of the visual effect, so you are aware you're inside the color choices. Over here, if you zoom over, you see this is actually happening in the intersection called ERAMP, the first ERAMP of I8. So what we could do, we're going to, from this list, we'll be able to select ERAMP. Where's ERAMP? Yeah. And it automatically adjusts that. And, oh, no, ERAMP should be this guy. And this one, we'll just pick anything that is more important. Yeah, so with this major route to this ERAMP, we're talking about So this way we successfully update this. In addition, you see with the temp review status. So these are the domains that we need to, and the source, we say this is the ADA source. So with this, we'll be able to update. Now we cannot update. Why? Because we're in the update mode. We cannot commit. Update by this definition is temporal in nature. So we have to specify a effective date. So let's say it was effective more than a month ago. Now we'll be able to update it. Once this is successful, if we come back here, and this particular record is actually quite a bit shorter now. And this one, yeah. So if I zoom in here, you will see, this gets retired, and this is the change date. This is new record we have modified and updated. So that's the update. Then let's look at correction. Correction is essentially when you turn up observation day, essentially treating each and every record in your possession in the database as equal. And we're seeing this, so we can have overlap, I would think. Yeah, it should have identify some of overlap scenarios. But let's just pick any one. Okay, how about this? We are going to fix, oops. We're going to fix the error. You know, we have this gap. We know this gap was a careless data entry issue. So we click this guy and we drag it. Well, that's interesting. Well, okay. I guess I found out. And so basically, we'll be able to drag this and snap to it to have this fixed. And in fact, I just did this earlier, just half an hour ago. So that's interesting. And what I'm going to show you instead of this, I'm going to turn this on because this is an important feature. Okay. And for this guy, and if we do edit, we will be able to drag it. You see, as we drag it, the red shows it's dynamically telling us you're overlapping it. Overlapping is not allowed. You can snap over here. This is snapping to an adjacent one, but you can right over snapping to this guy because gap is generally allowed, even though it could be a potentially an issue. So we can modify this in same location. So if you want to extend this to snap over to this line, you won't be able to save it because overlap is not allowed. So essentially, this is what I meant by guardrails. So we need guardrails to ensure we don't have making those data entry mistakes. So, and we also have, I know I'm running short of time, and we also have ways to essentially right-click. We can export data into CSV files and shape files, if you will, and we can merge. We can split by time and split by measure. I think I'm running short of time, and let me just quickly have a closing slide if I can find it. Okay. So that's the Ninja demo shortly. And, you know, I would like to say all this is built on top of Esri architecture. And it's the ArcGIS server and portal and, of course, database. It's similar like the event editor. What we're adding is some of the auxiliary services that we feel like we need to do to deal with some special situations. And I have to say, we are not oftentimes we take Esri for granted. We're not showing enough love for Esri. And Esri server platform and the fact it opens up its API is just very great. And that is the way that we can, in this open world, to make things connected, to improve, to come up with specific applications to resolve a problem, specific problems like what we're having. So, and my last slide. So Ninja, as an application, is still under development. We're adding batch operations. We're adding on-the-fly cross-layer QC. And these two are pretty significant, but we are hopeful later this year or early next year, we'll have it ready. And with that, I'm asking any questions, and maybe you can entertain questions later. Sorry about my overstepping the time.
Thanks, Bo. Yeah, we're so much to cover. I think if there's questions, if you guys could type them in the chat, and maybe Bo can address them through there. Because we're running short on time. We need to give David time to show his app. And thank you, Bo. That was very informative. You got a lot of stuff going on there with that incredible linear referencing app. And I remember my days back in ADOT. That would have been very helpful back when I was there. So it's great how the technology has advanced.
Thank you, Jamie.
Okay, so
I don't know if I need a full intro. I can just start jumping into it. That's all right?
Sure. If you want to do a quick intro, I'm just going to turn it right over to David. Go ahead and share your screen, and he can introduce himself. Interest of time. Thanks.
All right. Hey, guys. I am David Olson. I work at the Department of Health Services, and we're going to be thanks you guys for coming. That was actually really cool. I think anybody else get reminded of like iMovie editing or like GarageBand, Bo's like dragging the tracks along. It's kind of cool. Anyway, so this presentation is going to be on the Hospital Compare site, and there's definitely not enough time to get into like the functionality of the site and its features and all that kind of stuff. So it's really just going to be about some of the design choices and some of the considerations that we had to make to display the type of data that we had. And just tiny background is there's like over 100 hospitals in the system. Each hospital has thousands and thousands of attributes and records that stretch back over a decade. So there's tens of millions of records in here. And so now I will show it a little bit. So here's the landing site. And at first glance, it maybe doesn't look exactly like a typical GIS application or site, but I assure you it's all built from with GIS in mind. And so like, this is our search that use querying RSDE. We go and try and find a hospital or facility. Obviously, we will recognize this type of interface. And this is where it's, we kind of display things a little bit differently. We still are showing our geographic information, and this is sort of the top 10 most common diagnosis at that place. The tabs here along the top are the sources of the data information. This tab's quality of care is from CMS. This is from AHRQ. This is from the HDD hospital discharge data set. Within each NDC, there are nested DRGs, diagnostic related groups, and major diagnostic category. All this jargon is not important for the purpose of this presentation, so don't worry about it. But I think what is interesting to note for this audience is that this really is a GIS display, right? This is a single point of geography in this case, and this is essentially an attribute table, right? It's just displayed in a sort of unique, or it's a different way to present it. And I can kind of really show that by going to the Compare Hospitals site here. It's a different tab, the menu. And what we have here is the same exact data that was being displayed before is being displayed here. It's all in the same database. It uses the same custom API built. It is all, the same queries and everything. It's just in being how we render that and display it, depending on our use case, changes. And so this is, much more traditional dashboard layout where you have your queries, your searches and filters. You can download and do all that stuff. You have your map interface with your hovers and your kind of a custom layers and legends and a custom sort of a mapping, charting interface where you can display things over time. So we can see that they're both really the same kind of data set, right? But, so why did we need to have in both of these different display types, especially considering this kind of is what we're familiar with, right? This is the cool, it seems like everything's here. But I think if I stop sharing, will it make me big again? My screen?
Yes, it should put you back in the middle.
Oh, I'm going to start video. There we go. Stop sharing. Now, hopefully I'm big. If not, you guys will have to squint. Sorry. So the reason why is I was trying to think of a way to explain this. I built this fun little cube where in our data, where we have here, we're trying to display, we have these pink represents a hospital or facility, and blue represents data in this case, or an attribute, you could think of it as. And no matter how you spin this cube, you can either only see multiple geographies with a single attribute, or you can see, I can spin it in the camera and backwards, a single geography, like a hospital in this case, with multiple attributes. And that's really why we had those two different views. And I know some of you may be thinking, well, you know, that's not true. We can try and get clever here, and like, you know, use a mirror, try and, example there. I had to go find a mirror, and I realized I didn't have any, and I had to go raid the wife's makeup closet. But so I wanted to show that we did try and think about different ways that we can display multiple geographies and multiple attributes with over each other, but we really couldn't find an ideal solution. Everything we came up with either made it overcomplicated to display, or it made it like trying to use like time space cubes and trying to use bins as attribute values, and we tried these different visualization models, and really just kept coming back to the idea that it's not going to be easily understandable and congestible for the users that we're targeting, or anybody really. It's just kind of a confusing thing unless you're really deep into data science. It's not an easy topic to grasp. So with that in mind, that was the example of, I can actually go back. Let's see, I'll search for, actually, go to this profile. And so, yeah, so this is like that. I was just saying, this is the example of a single geography, a single pink box there, but you can see many different types of attributes associated with that. And now let's run through sort of a use case. Looks like I got 7, 8 minutes or something. So sort of a typical use case of what you could do with this application is you can go find a hospital that's near you, and you can go and see what it specializes in, or what are its most common procedures and diagnosis that it deals with. And then you can kind of just explore these data sets. There's tons of additional reading. You can click on any of these, on any single data point, and get a lot of extra information about it and read even more. So in this case, we're saying, oh, well, this looks pretty good, right? This death rate for pneumonia patients here is lower than the national average. Seems to be good. And so maybe if we wanted to go and see, well, that's great for this hospital, but how does it compare? It compares nationally, but how does it compare to the other hospitals in the state? So if we click that tab, it'll bring that same query. Like I said, these are all using the same underlying database. So now we can bring that query over and compare it across different geographies. And so now, if we wanted to say sort by the score, we can see that this Mayo Clinic is it's actually one of the best in the state, because the lower number is better in the situation. And so then if we're looking at that and we're like, okay, that's interesting. So what else does it seems to be good for pneumonia. So let's try searching for lungs. I'm not going to try and spell pneumonia on a live demo. I found something here that also seems like it's got some kind of pneumonia-nectomy in it. I'm definitely not an epi or medical trained professional or anything like that, but so I just had to kind of learn all these terms and stuff as I went. But here we can see this is another similar type procedure, it seems like to me, and if we go and kind of sort by the number of total discharges for that, we can see, oh, this is one of does some more than, you know, a lot of other facilities. It also has relatively low charges compared to the other facilities in its region. If we wanted to show by, say, charge, but then sort by discharges, we can kind of get a good picture of how it's got lower charges, but more discharges. And you can kind of think of it as maybe if this facility treats these type of patients a lot and does this procedure a lot, maybe it's probably going to give you a more effective result because they're used to doing this procedure. It also has overcharges. So maybe if I was going for this type of procedure or wanted to know more, this would be a hospital I'd be interested in going to. Of course, there's a lot of different variables and things that go into healthcare. I'm not trying to say that this is a one stop to choose your healthcare. Of course, all the disclaimers and stuff aside. But that's sort of the general idea of how you could use it. And then if you wanted to go a step farther, well, we have the advanced options here. These will sort by, you can apply additional filters. You can only do one filter at a time, of course, due to confidentiality and suppression and HIPAA. We need to make sure that there was no chance of releasing any PII or anything. That's also why we do a year-long aggregation. There's a little bit more data available if you go to the counties. The county, I'm not going to show all that. It's the same exact interface with the profiles being all the attributes for a single county and the compare counties being all the geographies for a single measure. It's just interesting to know with the counties, if you do look at those, it's not based on like just a summing up of all the hospitals in that county. It's actually based on the patient residence. So it's a completely different set of information than you will get from the hospital profiles. So I really went fast there. I think I'll show you guys. You see my craft I just did. I literally made that just a few minutes before. So I think I actually do have time for questions. I will, I guess, open it up to questions. I think that was hit the core topics I wanted to hit on.
Hey, does anybody have any questions? Looking through the chat. People love your great visual aid, your little thing that you made. Does anybody have any questions for David? And in case you missed it, his app is also featured in the Maps and Apps. There's a link to it, and you can also get to it directly. But of course, I'm making you go to the Maps and Apps page.
Yeah, here's my fancy my fancy slide. I figured we're all really taking this teleconference casual thing, so taking the casualness very seriously.
I think that was great. If nobody has any questions for David, that was pretty cool. I did check out your app and played around with that yesterday when I was checking out all the different apps. That one was really well done. That's a lot of work. I want to say, if there's no more questions, thanks to all of our presenters, our three presenters. You guys did great. I know it's a lot to cover in such a short time. Everybody did great. And for those of you in the audience still around here, here's another link that takes you back to the session page. There's a link to a survey there. So if you could just fill out a quick survey, it's really, honestly, it's only 2 questions. So just to tell us how this session was and what you liked about it, and if you haven't done if you've seen other sessions and want to fill out the survey for those, go to their pages and fill out the survey as well. So with that, more questions. I want to thank all of our presenters. Thanks, David. That was great. You did great in such a short time. And Bo and Kacie, thank you guys so much. And next up, you guys, if anybody wants, the sponsor breakout sessions are starting up. If you want to go in there and mingle and see some of the new stuff coming on. I'm not sure which sponsors are in that one this time. Apologies, I don't have that in front of me. And then at 3 o'clock, we're doing some awards and stuff. So be sure to catch that with the full group at 3 o'clock before the 3:30 sessions start up. I guess that's it. Thank you for what, aw. Who's that? What's their name? She or he?
This is a little Toulouse. It's David Boy.
Oh.
Hi, everybody.
All right. Thank you.